Okay, ladies and gentlemen, 8.4, surface area of a cone. And surface area of a cone would include this whole top slanty part that goes all the way around. That's the lateral area, as well as the base area, okay? So let's talk about the lateral area first. And we're going to take a few notes. Use proportional reasoning. So that just means think about proportions to find the lateral area of a cone. And we've done some thinking through that already with our investigation. Use proportional reasoning to find the lateral area of a cone. The ratio of the areas is the same as the ratio of the circumference. Circumferences. I'll explain that in a second. So in your investigation, you learned that the circumference of the base of the cone is proportionate to the circumference of the original circle that the sector for the cone was cut out of. Okay? What does that mean? We cut out 1/4 and we were left with 3/4 of the circle. So the circumference of the base of the cone was 3/4 the circumference of the original circle. Okay? That's a proportion. It's a ratio. It's a comparison of two numbers. Now,
that actually makes sense now.
the same is true of the area of the base of the cone, which is just this surface area of that circle that forms the base of the cone, and the original circle, the area of the original circle. Okay? In your example that you cut out, the area of the base of the cone will be 3/4 the area of the original circle because you cut out 1/4 of it. Now that seems pretty obvious.
Is that the case
Okay?
for all the cones?
So that is true. Yeah, if you were to cut out only, let's say, 1/8 of the circle, okay, then the cone that you formed would be flatter and wider, and the base, the circular base, would be bigger. It would be 7/8 of the original area. The circumference of that base would be 7/8 the circumference of the original circle. Okay? Hopefully that makes sense. We're going to write a couple of fractions that will help us understand that a little bit better. Okay? So pay attention. You might want to see what I'm writing before you write it here. But you're going to write a fraction with lateral area of cone over,
where are we supposed to be writing this?
at the bottom of that page under the notes section.
Oh,
Rip in the chat.
Yeah, right where it says 8.4 notes. Okay? Area of circle.
the top of the list section.
Yeah, because it will never fit. Okay, and that's going to be equal to this ratio,
Can I just finish from the top?
circumference of cone over the circumference of circle. Now this is exactly what we already described, but it's just written as a proportion. A proportion is when you set one ratio equal to another ratio, and now if you know bits and pieces of each ratio, you can figure out the missing answer. You can figure out an unknown value this way. So for instance, if we know the lateral area of a cone and the area of the circle, using our formulas and using radius, etc., and the slant height, then we can also figure out one of the missing pieces here, okay? Okay, here we go. This part is going to get a little bit confusing. Please try to follow along. So we are going to consider a cone with slant height S and radius r. So what have we done? All we've done so far is we have a cone. Okay, it has radius of r and a slant height of s. Okay, does that make sense to you guys so far?
Yeah.
So we haven't measured the height of the cone yet. We just have the slope height and the radius of its base. Okay?
Okay.
So that's what it means when you say you have a cone with a slant height of s and a radius of r. We could say a slant height of 4 and a radius of 3, and that would give you exact numbers, but this is a general example, okay?
Yes.
Here we go. Now, the circumference of the large circle is, let's think about this. So basically, just like in your investigation, this cone was made from a larger circle. How would we find the circumference of the original circle that we cut this cone out of?
Well, you have to do.
Let's say
find
that-
out what the slant is, and then you times it by 25. Nope.
So the slant of the cone is equal to the radius of the original circle. Okay, so to find the circumference of the original circle, we take 2 pi s. So 2 pi r is how you get circumference, but the radius of the original circle is the same as the slant height of our cone. Okay? The circumference of the base of the cone. What's the circumference of the base of the cone?
Is 3/4 the original circle?
You're right, it will be. That's very good thinking. We're going to get to that in a second. But what's the formula for it? The base of this circle.
And then 3/4.
It's just 2 pi r. Yeah.
Yeah.
2 pi r. Nice. Okay, a couple more notes. The area of the large circle is what? So what would have been the area of the original circle that we cut this cone out of?
3/4.
Well, don't think about that. You don't know how big of a cut you took out of it yet or anything like that. All you have is that it has a side length of s and a radius of r, which means the original circle has a radius of s. So what's the area of the original circle?
Pi r squared.
2
No,
pi s.
2.
Pi s squared.
Pi r squared, but r is actually
S.
s.
Pi s.
Pi
Oh.
s squared.
What do you mean?
Why is it s?
The radius of the original circle, the radius of the original circle is s. Okay?
Oh, okay, this is making sense.
Here we go. So now we have 3 pieces of information that fit into our proportion. Okay? So let's replace some of these things. We do not know the lateral area of the cone.
What's lateral?
What-
Lateral area means the whole top part of the cone. So the surface area of the cone, not including the base. Okay? So what
yeah.
you have, because you don't have a base on your cone, so what you have is the lateral area of a cone. Okay? So here we go. Let's fill in what we know. We do not know the lateral area of cone. So we just leave that there. We do know this bottom part of that side of the proportion. We do know the bottom part of the ratio. The area of the circle. Right here. The area of the large circle is pi s squared. So let's put that in there. And on the other side of the proportion, do we know the circumference of the cone? Yep, the circumference of the base of the cone is 2 pi r.
Is this going to be on the quiz tomorrow?
No. And the circumference of the large circle, the original circle, is 2 pi s. All right, again, this is the general case. This is just helping you understand how we get these formulas. Once we get into the examples, you'll just have to use the formulas. But here we go. We can reduce these. We're going to use this to generate a formula for the lateral area of a cone. We're going to find out how to get the lateral area of the cone just from S and R. Okay? So on this side, 2 pi and 2 pi cancel out. Okay? If you have 2 over 2, it's just 1. Pi over pi is just 1. So this right side reduces to R over S. So now we have the lateral area of cone over pi s squared is equal to R over S. Now, if I'm trying to isolate the lateral area of the cone, what should I do next? I want to get this
pi by itself.
I want to get this numerator by itself. Right now it's being divided by this big chunk. So what do?
Multiply by pi.
I multiply it by the whole denominator. Okay? So I'm going to multiply both sides by pi s squared. On the left, that's just going to leave us with the lateral area of a cone. On the right, we have R over S still. And we're going to multiply that by pi s squared. Now, still paying attention. Whenever you multiply a fraction by a whole number, when you multiply R over S by pi s squared, basically what we're just saying is that this whole pi s squared goes into the numerator. It's going to get multiplied by R. Does that make sense? Okay? Which means that it's being divided by S. Now we have an s squared in the numerator and an s in the denominator. So this s in the denominator cancels out one of the s's in the numerator. Okay? So now we only have one factor of s left in the numerator, and we don't have any factors of s left in the denominator. We just have 1 in the denominator, and anything divided by 1 is just itself.
Wait,
So-
so those 2 s's canceled out?
No.
There's 2 s's in the numerator and 1 s in the denominator. So 1 in the denominator cancels out 1 in the numerator. You're still left with 1 in the numerator. So here I'm going to write down what's left over. The lateral area of the cone is equal to R S pi, or pi RS is how you'll usually see it. Let me write it that way. Pi RS. Okay? So there's a formula for the lateral area of a cone. The formula for the base of the cone is really easy. It's just the area of the base of the cone is pi r squared. Okay? And the area of the cone, the lateral area of the cone is pi RS. So that allows us to get the surface area of a cone, and this is the key formula that we're going to be using, is the lateral area, which is pi RS, plus the area of the base, which is pi r squared.
Why and R? You got radius?
Yep.
Yes, sir.
Okay, where r is the radius and s is the height of the slant.
Oh, isn't it the slope?
It's not the slope. Slope is a measurement of the right of the steepness of a line.
No, slope is f.
It's called the slant height. Okay, it's not the height of the cone. That would be this guy.
Yeah.
It's the slant height, and r is the radius. Okay, so this is the formula we're using. I would write that at the top of all of your homework pages, and let's start applying that now. Example 1, please. Surface area of a cone. There is only one example for this lesson. Nope, I put a second one on there, so we'll do that as well. Surface area of a cone. Calculate the surface area of the cone to the nearest square centimeter. Okay, so we want to use the formula to use the formula.
Now should we be on page example 1?
Yep, example 1. To use the formula for surface area of a cone, we need, what variables do we need to know?
The radius
We need R
and a slant.
and S. Okay, look at your diagram. Do you have R?
Yes.
Yep. Do you have S?
No.
No.
Pythagorean theorem.
Okay. So use Pythagorean theorem.
What is T again?
And we need to pay attention whenever I'm using Pythagorean theorem and I'm not sure which sides I have and don't have, just draw a quick diagram, okay? So right now you have, if you were to take a cross section of that cone, you would have a radius of 3 centimeters and a height of 8 centimeters. So in this case we are indeed missing the hypotenuse, which actually we're going to label S, okay? So we know S squared is 3 squared plus 8 squared.
Wait, no, we know what A is.
S squared
Finding for X.
is 9
Oh,
plus
yeah.
64.
Why'd you put S there?
Because
It's easier to do at the end.
Because S is taking the place of C.
S squared is,
73.
so S is the square root of 73, which is approximately 8.5 centimeters. Okay? I know that's not my final answer, but I'm going to put a box around it just so I can keep track of what I'm doing. And now we can take the surface area of a cone is equal to, go ahead and flick back and get your formula. Try to memorize it. Pi rs plus pi r squared. And we can sub in what we know. We know r is 3. And we know s is 8.5. And then the second portion, pi r squared. Pi times 3 squared. You could just do this part in your calculator. You hit 3 times 8.5 times pi. 3 times 8.5 times pi. Keep a decimal place until you're done.
80.1.
And 9 times pi.
9. Oh, no. It's 28.2.
Add those up.
When did you tell me
No, because you don't round to the next one.
What did
Three.
No, what did it?
I got
It is 3.
Okay, that's fine.
Is that
Because we're going to round to the nearest square centimeter anyway. So the surface area of this particular cone is approximately 108, and its area, so it's squared centimeters. The question also told us we were dealing with square centimeters. Okay? So again, we're just applying our formula that we derived in the investigation and in the notes. And in order to use it, we needed R and S. We didn't have S, so we used Pythagorean theorem to figure that out. Okay, step 1, step 2,
if you
done.
remember the thing, it's easy, but I won't remember.
In the second example, the surface area of a cylinder, okay? This is like a mini lesson inside this lesson. So example 2, surface area of a cylinder. The surface area of a cylinder includes 2 circular bases that are identical and 1 lateral area that forms a rectangle. If you were to do a net for this thing, you would end up peeling a rectangle away from the 2 bases, and the 2 bases would be identical, okay? So this is what the pieces that we need to remember to add together for a cylinder. So what's the formula for the area of a circle?
Pi r squared.
Pi r squared, and we're going to have 2 of those in our formula. And the area of a rectangle, just length times width. So, in order to get the area of a cylinder, surface area of a cylinder, we need 2 pi r squareds, right? We need 2 of those circles, plus length times width, or LW. Another way to think about this is the idea that the length of the rectangle is actually the same as the circumference of the circle. Does that make sense? The length of this side of the rectangle
Okay.
is actually the exact same as the circumference of this circle because it wraps all the way around the circle. Okay?
So, we find
So when we're
time
talking
by-
about L, I'm going to do this on the side and then I'll erase this. L is actually the circumference, which is
pi equals 2r
2 pi r, right? Diameter times pi is the circumference. And the width then, this part, how does this side relate to the cylinder?
It goes over there. That's the height.
It's the height of the cylinder. So the width is actually the height of the cylinder. So our formula is actually 2 pi r h,
But
because it was length times width. We said the length is actually 2 pi r.
should I write that?
So 2 pi r times width, which is actually h. Okay?
Should I
So
write
this
that, Will? Yeah.
is the formula that you need.
That's a long formula.
Alright, let's quickly apply that formula to the diagrams that you have there. In A, you have a diagram that has a height of 7 and a radius of 4. Alright? Let's plug it in. So the surface area of the cylinder equals 2 pi r squared plus 2 pi r h. Sub in what we know.
I don't get that.
2 times pi times r squared, which is 4 squared, plus 2 times pi times r, which is 4, h, which is 7. Okay, over here you have 4 squared is 16 times 2 times pi. So you've got 32 times pi. And on the other side you have 4 times 7 is 28, times 2 is 56. You have 56 pi. So how many pi's do we have? We've got 32 plus 56. You have 88 pi's. And the approximate answer for that, 276.5. And let's just round to the nearest whole number. Round to the nearest whole unit. And the units aren't given in this situation, so look at what you do. Square units. Okay, if the units are not specified, they're still squared. So you have to note that they're going to be squared units. Alright? I'm going to shimmy on over to B.
Is there a symbol for unit?
Square units.
Is there a symbol for a
If
unit?
you know a particular unit, then yes, like centimeters or meters or kilometers or liters. But not if you don't know. Then it's units. Okay, the next one you have a radius of what?
2.
And a height of?
6.
So all you need to do is take your surface area for a cylinder, 2 pi r squared plus 2 pi r h. Plug in your numbers. 2 pi 2 squared plus 2 pi times 2 times 6. 2 squared is 4, times 2 is 8, so you've got 8 pi. 2 times 6 is 12, times 2 is 24 pi, which gives you a total of 32 pi, which is approximately
Is that a 2 or a 6?
101.
101 square units. Alright, ladies and gentlemen, you learnt the formula for the surface area of a cone and for the surface area of a cylinder. You don't necessarily need to remember where they come from or why they work, and you won't need to memorize them. You'll just need to know how to use them, to plug in the numbers and apply them to get the surface area of the given form. The homework for this lesson is in your workbook, in your notebook, but you can complete it in your homework workbook.